Hello everyone, and welcome to the Matplotlib Part 2 lecture series. We're going to pick up right where we left off in Part 1, where we learned about functional programming with Matplotlib, and more importantly, the object-oriented methods with Matplotlib. Let's go ahead and jump back to the Jupyter Notebook to get started. Okay, here I'm back at the Jupyter Notebook. Remember from last time we learned how to use plt.figure and then fig.addAxis and then axes.plot in order to plot onto an object-oriented figure using Matplotlib. The next thing we're going to do is learn how to create subplots using the same object-oriented programming method. I'm going to go ahead and say here, let's just clear everything in this cell. And we're going to go ahead and say this. Let me move this cell to the center, and we'll say fig, comma, axes is equal to plt, and instead of calling figure now, since we're going to try to do subplots, we're going to say subplots. So plt.subplots. Let's go ahead and run this. And notice here we get subplots, just out. Now what I can do is just use the axes object like I've done before to plot on it. And this is essentially no different than what we were doing before. And here we said axes.plot x comma y. Where subplots differs is where you can specify the number of rows and columns. For instance, I can say n rows as my first argument is equal to 1, and n calls as my second argument is equal to 2. And I'm going to go ahead and just show you what that looks like. I'm going to hashtag that out and run this. And now you can see I have one row with 2 columns, and that's basically just a nice front handle on calling plt.figure. All subplots is doing is essentially calling these fig.addAxes automatically for you based off of these arguments of n rows or n columns. Let's go ahead and play around with this. Let's go show one more example. 3 rows by, let's go ahead and say 3 columns. And we can see now we have 3 rows by 3 columns. Later on we'll see how to deal with the issue of stuff overlapping, but it's essentially just a one-line call. We just say plt.tightLayout, and that actually ends up fixing those overlaps. But let's go ahead and take a step back and just work with this 1 by 2. Alright, we have plt.subplots, and essentially it's just an axes manager on top of plt.figure. Something to note here is that instead of just saying fig equals plt.figure, I am doing some tuple unpacking. I'm saying fig comma axes is equal to plt.subplots. And the thing to note about this axes object is if I go down here to this cell and type in axes, axes is actually just an array of matplotlib axes. Essentially, it's just a list of these axes object, meaning I can actually iterate through it. I can say something like this. For current underscore, ax in axes, axes.plot x comma y, and I don't actually want to say axes.plot, I want to say current ax.plot. And then we see that we've actually plotted through this axes. Again, this is just to show that this axes object is essentially just a list of matplotlib axes, which are the ones that you manually created when you said fig.add_axes. Just further driving the point home that the only difference between plt.subplots and just doing plt.figure is that plt.subplots is essentially doing this add_axes stuff for you automatically based off of how many rows and columns you want. Okay, since we can iterate through this axes object, we can actually also index it, meaning I can say axes 0 dot plot x comma y. And here I've plotted on this first axes, and I can do the same thing for the second one. I can say axes 1 dot plot y comma x. And here we've seen how to either index call off of this axes array or iterate through this axes array. And just like we saw earlier, we can also call titles and labels off of this. So I can say something like axes 0 dot set title. We'll say first plot, and then I will say axes 1 dot set underscore title second plot. And here we're able to call titles. And you can say set X label, set Y label off of either of these axes objects. All you're doing is just actually grabbing that axes subplot object based off of its position in the array. All right, let's do a quick review of these two object-oriented methods. This first method is a little more manual. It's pt2.figure. You go ahead and create that figure. You manually add the axes and choose its location and size. And then, based off of that axes, you go ahead and say .plot and .set title, set X label, set Y label, etc., which we show examples up here. The second method is for subplots that you want arranged by rows and columns. This allows you to call fig, axes, so tuple unpacking here, is equal to the subplots call. And then, based off of those axes, you get an array of axes, and you can plot and set titles either by indexing or by iterating through that axes object. And if you ever have any issues with things overlapping, you can always just say plt.tightLayout, close parentheses, and this will take care of any overlapping plots. I recommend that you just always put this at the end of your plot statements. Okay, now let's start talking about figure size, aspect ratio, and DPI. Matplotlib allows you to control each of these aspects, and you can specify them when you're calling the figure object. Let me go ahead and show you an example. I'm going to say fig equals plt.figure, and the arguments I can pass in are fig size is equal to, and then you pass in a tuple, where the tuple is the width and height of the figure in inches. For instance, I can go ahead and say 3 by 2, and then a second argument you can add is DPI. For instance, 100 DPI, where a DPI is just the dots per inch or pixels per inch. I usually just use the default DPI when I'm working with the Jupyter Notebook, so I'm going to go ahead and just clear that for now. I'm going to add a set of axes to this. We'll call it just ax, and we'll say fig dot add underscore axes, and we'll say 0, 0, 1, 1. And then I'm going to go ahead and say ax.plot x, y. All right, so there's our plot. Let's go ahead and mess around with the figure size. Let's say we wanted this to be very wide. I could go ahead and say 8 by 2. And now I have this to be 8 inches by 2 inches. All right, so you can do the same thing with subplots. So I could say plt.subplots, set that fig size. Remember here, now we're going to say fig axes, and I'm going to go ahead and remove the add axes, set the figure size, and set axes. We'll go ahead and plot onto the first axes. I'm going to just say axes.plot xy, and I get a very similar plot. Now I'm going to go ahead and specify some rows and columns for this subplot. We'll say n rows is equal to 1. Let's actually make 2 rows since we're going wide here. And then let's say we have 1 column. So n calls is equal to 1. Now I'm going to call 0 here, plot x, y, and then we'll say axes 1 dot plot y, x. And here we can see the fig size has taken this into account as far as 2 rows by 1 column. And as always, since we have a little bit of overlap here, you should try saying plt.tightLayout. And this will attempt its best to fix out the tight layout. And it looks like it did a pretty good job here. There's some issues here with this y-axis, but we'll show you later how you can customize this y-axis to show a little less information. Alright, now that we've finished discussing figure size and DPI, let's go ahead and make a new cell and begin discussing how to actually save a figure. In order to save a figure, you can use Matplotlib to generate just high-quality outputs in a number of formats, including PNG, JPEG, EPS, SVG, PGF, and PDF. To save a figure to a file, you can use the savefig method. So for instance, we have our figure here that we already created. Remember, that's just right here, fig. And then I can say fig.save fig, and all you have to do is pass in the file name you want. So for instance, my underscore picture, and then you pass in the extension, and Matplotlib is smart enough to know what you want. So if you want a PNG, you just say .png. If you want a JPEG, you say .jpeg, .jpg, etc. Let's go ahead and save this as .png, and that will automatically save the figure. Here you can also specify the DPI. So if you forgot to specify the DPI over here when you were actually creating the plot, you can specify again the DPI over here. So you can do this with like a 200 DPI. Then you can increase the DPI as you want more detail. Alright, we've already gone over figure titles and axes labels, such as set the X label and set the Y label, but let's show you a quick reminder of how to do that. I'm going to change this back to just a simple fig equals plt.figure. We'll go ahead and add a set of axes to this. So we'll say fig.add_axes. We'll put them at 0, 0, 1, 1, and then we'll say ax.plot x, y. All right, so as a reminder, if you want to add a title, you take one of these axes and you say set title, and you just pass in a string of the title you want. In order to set a Y label, you just say set Y label, pass in a string of the Y label you want, and then for X label, you can do the same thing. Set the X label you want. Okay, so I have my title, my Y label, and my X label. Let's talk about legends. With legends, you can use label text to actually clarify what plot is what plot. And I'll show you what I mean by that. I'm going to go ahead and remove these 3 lines of code and say ax.plot y, x. So notice I'm just doing this on the same figure, meaning if I say and actually run this, I will get 2 lines here. I will get the xy plot and the yx plot. Since these are quite different, let's go ahead and get something that's a little more similar. I'm going to go ahead and plot x versus x squared and x versus x cubed. Alright, so now we have 2 lines here, and if you were just looking at this figure by itself without being able to reference the code, you're probably a little confused as to what each plot represents. You would want to add in a legend. And in order to add in a legend, it's actually quite simple, but it's a 2-step process. The first step is to just call ax.legend at the bottom of your code where your axes are defined. And if you run that, you will notice you get a warning. It says no labeled objects found. And that's where the second step comes in. For each of these plot calls that you just made, you're going to add in an argument called label. And this label is just a string that you want for the ax.legend function to be able to reference. Let's go ahead and show you what I mean by that. We can go ahead and say x squared here as our label. And then in this label, I'm going to go ahead and say x cubed. And now when I run this with ax.legend, I see I've been able to create a legend. So all this does when you call ax.legend is it looks for each of the plot calls and then checks to see if there's a label. And then this label, which is just a string, gets returned and gets matched up to the correct color of your line. And later on, we'll show you how to actually customize your line colors. Now, a quick note is that notice how some of this legend overlaps the actual plot. What you can do in the ax.legend call in order to avoid this is specify LOC. Now, there are actually quite a few locations you can specify, and I'll show you the documentation page real quick for it. It's linked in your notebook in this section. Let me go ahead and go to that link. So that link will take you to a page that looks like this, and you can click legend, and there's basically a set of parameters here. And there's a location code and a location string. So you can specify the best upper right, upper left, lower left, etc. based off the location code. I would always recommend that you just use location code 0 because that allows Matplotlib to try to choose the best location for your legend. Let's go ahead and do that. We'll go ahead and say LOC equals 0, plot that out, and we see that the best location is over here in the top left. Let's go ahead and check out one more location code. If we go back here, for instance, if we wanted it in the center, we could specify location code 10. And here we have it in the center. Now, if none of these options are working for you, such as 0 through 10, What you can do is you can also specify a 2-tuple giving the x and y of the lower left corner of the legend. So for instance, we can go ahead and say something like this, 0.1, 0.1. And that means just like you did earlier when you're putting in an insert plot, you can put in a tuple here specifying the location of where you want your legend bottom corner to be. Alright, that's it for this second part. Coming up next on this last part of the Matplotlib concepts lecture, we're going to talk about setting colors, line widths, and line types, as well as working with markers, setting the plot range, and then we'll begin to talk about some special plot types, but that will lead us more into our discussion of Seaborn. Alright, thanks everyone. Go ahead and post any questions you have to the Q&A forums, and I'll be happy to answer them there. And remember to reference the notebooks for this lecture. Okay, I'll see you at the next lecture.